Hello everyone. The instructions say solve by substitution, and so it really is tailor-made for substitution. In other words, we already know what y is equal to. One of the variables has already been solved for the other variable. Y is equal to 2x plus 5. That's what makes it tailor-made. So what that means is wherever y appears in the second equation, we can simply replace it by what it's equal to. Y is equal to 2x plus 5, well, we can replace y with what it's equal to. So, wherever y appears down here, and it only appears here, I'm going to replace it with 2x plus 5. And this is what we get. So, solving by substitution. We are now in an earlier section of our textbook, section 1.3, one equation and one unknown. We have transformed two equations and two unknowns into one equation and one unknown by substitution. And you should be very familiar with solving these sorts of problems, as they're going to appear again and again, where we manipulate things so that they become one equation and one unknown. You're going to see that time and time again. What we need to do here is to do the distribution. And when we multiply both of these terms by -2, we end up with this. 3x minus 4x minus 10 is equal to -9. Now, we combine like terms on the left-hand side. 3x minus 4x is going to give us a -1x. And now what I want to do is simply add 10 to both sides. And when we do that, we end up with this, adding 10 to both sides. Now, this is an interesting moment I find when I grade papers. Quite frequently, people will stop right here, as if they've solved for x, and we need to reorientate you to make sure you don't stop here. For one, you're solving almost in every situation, you're always solving for x, not -x. So there's more work to be done. And for two, we're talking about a system of equations. And so if they intersect, they're going to intersect at an ordered pair. And we're only have found, as we move down here, we've only found one part of that ordered pair. So what's your move right here? How do you solve this for x and not -x? And the answer is you multiply both sides by -1, which is a sign changer. So the -x will become a positive x, and the positive 1 will become a -1. It's simply a sign changing moment. And I've already boxed it. This is half the answer. We now need to find y, the y component of the ordered pair. And we can use either of these two equations up here. I am choosing to use the top equation because when I put x equal to -1 in there, it's going to tell me directly what y is. There's less algebra to do, less chance of making an error. But be certain here, you can use either one of these equations. It just so happens that often one is a more judicious choice than the other. So again, I'm going to use this equation, and what I'm going to do here is, since I know the value of x, wherever it appears, I'm going to replace it with -1. When we do that, subbing in, we get this. And now, once again, one equation and one unknown, section 1.3, we simply multiply the 2 and the -1 to get -2, and add 5 to get a positive 3. And let me box that and show that. So there you go. The point, the ordered pair, -1, 3 is where those two lines intersect. It is the solution of the system. Now to check my work, I decided I'd use alpha Wolfram, and let me bring that in here, and let me scroll down. Notice how I put the input into the Wolfram alpha. I put in the first equation and then a comma, and then the second equation, and then I simply hit enter. And it drew me a picture showing me that the two lines, color-coded, did indeed intersect. And then it showed me what the solution was right here, which is a verification of what we found using our algebra. So I hope that helps. I hope I kept it simple. I'll be talking to you soon.